The world initially began seeing terrific pictures of the universe caught by the strong James Webb Space Telescope, JWST, sent off by NASA. This aggressive and historic venture has indeed altered how we might interpret the universe by sending back a progression of amazing new pictures. These most recent visuals have paralyzed researchers and devotees alike, giving bits of insight that challenge existing hypotheses and open up new domains of investigation dissimilar to anything we have ever observed. These pictures offer us a brief look into the most far-off and cryptic locales of the universe, pushing the limits of human knowledge to unknown regions. Before we begin, hit the like and subscribe buttons for more exclusive news. The JWST, intended to be the replacement for the Hubble Space Telescope, has surpassed expectations with its high-level infrared capabilities. This permits it to peer deeper into the universe than any other instrument before it. While Hubble provided stunning views of the universe in visible light, the James Webb Telescope essentially works in the infrared range. This ability empowers it to slice through cosmic dust clouds and uncover the secrets of star development, black holes, and early system evolution. The telescope's most recent pictures have revealed regions of the universe that were previously hidden from us, offering new information about phenomena that have long astounded cosmologists. One of the most critical pictures returned by the JWST shows a region of space so far off that it goes back to a couple of 100 million years after the Big Bang. This period in vast history, known as the Dark Ages of the universe, has been largely shrouded in mystery. During this time, the first stars and galaxies began to form, and the universe started to emerge from its primordial state. Interestingly, researchers are now seeing proof of these earliest formations with phenomenal clarity, permitting them to sort out the events that shaped the early universe. In these new pictures, thick billows of gas and dust, heavenly nurseries, can be seen birthing stars. These districts are among the most violent and turbulent in the universe, where gravity organizes gigantic masses of matter to ignite the atomic reactions that form stars. The JWST has captured intricate details of this process, showing stars in various phases of their development and offering a window into the life cycle of stars in a manner that has never been possible before. By studying these images, astronomers can learn about the conditions under which stars are born and how these processes have changed over billions of years. In addition to heavenly nurseries, the James Webb Telescope has also captured pictures of distant exoplanets, many of which have never been seen before. These worlds are found so far away that their light has taken billions of years to reach us, meaning we are seeing them as they appeared when the universe was still in its infancy. The telescope's unmatched resolution has revealed complex structures within these galaxies, including massive black holes at their centers and star clusters that are far older than our own Milky Way. These black holes are especially intriguing since they challenge our current understanding of how these objects form and evolve. Some of the black holes seen in these images are much larger and surprisingly active, suggesting they were already at an early stage in the universe's history. Speculations about how black holes develop typically suggest that they begin as small, dense objects that gradually accumulate mass over time by consuming surrounding matter. However, the JWST data suggests that some black holes may have formed fully developed or experienced rapid growth, compelling cosmologists to re-evaluate their models of black hole evolution. The pictures of these early galaxies also raise questions about how galaxies themselves form and evolve. Some of the galaxies observed by the JWST are surprisingly well structured, with defined spiral arms and central bulges, despite being so young in cosmic terms. This level of organization is astounding, as it was previously believed that galaxies in the early universe would be more turbulent and irregular in shape due to the violent processes involved in their formation. The discovery of these well-formed galaxies suggests that galaxy formation may occur much more rapidly than previously thought, which has significant implications for how we understand the universe's early years. The JWST has also provided a stunning new perspective on some of the most mysterious objects in the universe. Exoplanets. These are planets that orbit stars beyond our solar system. While many exoplanets have been discovered over the past few decades, we still know very little about their atmospheres and potential for supporting life. The James Webb Telescope's infrared capabilities have allowed researchers to study the chemical compositions of exoplanet atmospheres more closely than ever before. Some of the new images and data have uncovered remarkable findings, including the presence of water vapor, methane, and other organic molecules on certain exoplanets. These discoveries are particularly exciting because they bring us closer to answering one of the most significant questions in science: are we alone in the universe? The presence of organic molecules in an exoplanet's atmosphere does not necessarily mean that life exists on these planets, but it suggests that the building blocks of life are more common in the universe than previously suspected. These findings could ultimately lead to the identification of habitable worlds beyond our solar system, potentially influencing how we think about life in the universe. The JWST's new pictures also provide crucial insights into the final stages of stellar life. The telescope has captured detailed views of supernova remnants, massive clouds of gas and dust abandoned after a star explodes. These remnants are not only beautiful but also scientifically significant, as they are the sites where many of the heavier elements in the universe are created. When a star goes supernova, it generates massive amounts of energy that fuse lighter elements like hydrogen and helium into heavier elements like carbon, oxygen, and iron. These elements are then dispersed across space, becoming part of new stars, planets, and ultimately, life itself. The James Webb Space Telescope's new images, which delve into the earliest parts of the universe's existence, have opened a window into a broader context we could hardly comprehend. What makes these pictures particularly inspiring is not simply their beauty, but their ability to unveil secrets of the universe that were once entirely unattainable. These never-before-seen scenes of distant galaxies, nebulae, and massive structures compel us to reconsider what we thought we knew about the universe. While the pictures of far-off galaxies and colorful phenomena have captured the public imagination, one of the most astonishing revelations made by the JWST involves objects much closer to home, the outer reaches of our own solar system. The telescope's infrared sensors have been able to study the cold worlds at the edges of the solar system, revealing new insights into their composition and surface features. For example, the telescope captured a detailed image of Pluto's moon Charon, revealing an intricate landscape of icy plains and mountain ranges that had previously been invisible to us. These observations of the outer solar system could help scientists understand the formation of planetary bodies in cold, distant regions of space. The Kuiper Belt, a vast region of space beyond Neptune that contains thousands of icy objects, has long been a mystery to astronomers. The JWST's ability to focus on these objects in detail could provide new insights into how planets form in the outer reaches of solar systems, offering clues about how our own solar system came to be. Beyond individual discoveries, the James Webb Space Telescope is also helping to answer one of the biggest questions in astronomy: how did the universe evolve into its current state? By capturing images of galaxies, stars, and planets at various evolutionary stages, the telescope is helping to create a timeline of cosmic history. These observations allow researchers to track the evolution of galaxies and stars over billions of years, providing a more complete picture of the universe's past, present, and future. One of the key revelations from the JWST's latest images is the realization that the universe's early years were much more dynamic than previously thought. The pictures show galaxies forming at a faster rate than expected, with intense bursts of star formation occurring in rapid succession. This challenges the long-held view that the early universe was relatively quiet and that galaxy formation happened slowly over billions of years. Rather, it seems that the first few 100 million years after the Big Bang were a time of extreme activity, with galaxies rapidly forming and evolving in ways that scientists are just beginning to understand. The James Webb Space Telescope's ability to look so far back in time is largely due to its exceptional sensitivity. By observing in the infrared range, the telescope can detect the faintest signals of light that have traveled billions of light-years across space. This light, emitted by stars and galaxies in the early universe, has been stretched and redshifted over time as the universe expands. The JWST's capacity to capture this ancient light allows researchers to see objects that are so far away their light has taken almost the entire age of the universe to reach us. As well as looking deep into the past, the JWST is also providing another perspective on the structure of the universe.